Hello everyone. I'll be explaining multi-stage graph in this video with an example. Now here is a directed graph that is given which has associated weight with respect to the edges. Vertices are divided into different stages. So here the source vertex is the first stage, and then in the second stage we have vertices 2, 3, 4 and 5. In the third stage we have vertices 6, 7 and 8. Fourth stage we have vertices 9, 10 and 11. And in the destination stage, that is the fifth stage, we have one vertex 12. Now the objective of this problem is to find the path from the source to destination, which will give the shortest path or the shortest distance or minimum cost as per the weight is given. Now since we are finding minimum weight, it is a minimization problem. That is, it is an optimization problem which can be solved using dynamic programming. Now let us consider in this case we will be considering the destination vertex and then moving backwards as discussed in the previous video of multi-stage graph. So let us find the distance between uh, the fifth stage 12th vertex to the destination. Now whenever we write this cost of 5 comma 12 or cost of 4 comma 9, it should be read as fourth stage ninth vertex. When I say cost of 4 comma 9, it means that it is in the fourth stage ninth vertex. So here cost of fifth stage 12th vertex to reach the destination is 0 because 12th vertex itself is the destination vertex. So it is 0. So in the table, we have a table for cost and distance or the cost and the destination through which vertex we are moving. So here cost is 0 and we are moving to the 12th vertex. Now we have completed with the fifth stage vertex. Let us move backward to the fourth stage vertices. Fourth stage we have three vertices, that is fourth stage ninth vertex, fourth stage 10th vertex and fourth stage 11th vertex. Let us find the cost of fourth stage ninth vertex to reach the destination. That is cost of 4 comma 9. It is given as the weight of the edge, which is 4. Cost of 4 comma 10 is 12. Cost of 11 4 comma 11 is 5. Let us enter these values in the table. So table says cost of fourth stage ninth vertex is 4. The cost is 4. 2, that is the ninth vertex. The topmost row indicate the vertex. Ninth vertex, the cost is 4 to reach 12. 10th vertex, the cost is 2 to reach 12. 11th vertex, the cost is 5 to reach 12, or we are reaching the destination through this node 12. Now let us go back to the previous stage, that is the third stage. Now here you will notice the difference between the fourth stage and the third stage in this case is from the fourth stage you have only one edge. Whereas in the third stage you will see there are two edges that is coming out of 6. Now how do we choose? Our objective is to choose the minimum cost. So we need to find which is the minimum cost from each of the vertices in the third stage. Third stage we have three vertices, that is 6, 7 and 8. We need to find what is the minimum cost to reach 12 from 6. So we'll say cost of third stage sixth vertex, that is cost of third stage sixth vertex is minimum of the cost of this edge, that is 6, that is the edge from 6 to 9, that is written as C of 6 comma 9. That means the cost of this edge and the cost of fourth stage ninth vertex, comma cost of 6 comma 10, C of 6 comma 10, here it is 5, plus cost of fourth stage 10th vertex. So where do we get the cost of fourth stage 9th vertex and fourth stage 10th vertex? We get it from the table here. Fourth stage 9th vertex, the cost is 4, and fourth stage 10th vertex, the cost is 2. So let's calculate minimum. Minimum of C of 6 comma 9 is 6 here. So 6 plus cost of 4 comma 9, it is 4, and C of 6 comma 10, the weight of this edge is 5 and the cost of this particular vertex is 2 from this particular table. So minimum of 6 plus 4 and 5 plus 2 is 5 plus 2, that is 7. Who is giving me this answer? That is C of 6 comma 10 plus cost of 4 comma 10. So it says that from 6, if I move through 10 to 12, I will get a minimum cost. We can just cross check here. If I move through 9, what will be the cost? 6 and 4, that is 10. If I move through 10, what will be the cost? 5 plus 2, that is 7. So I am choosing this for third stage, sixth vertex. So sixth vertex, the cost is 7 and I am moving through 10 to reach the destination. Similarly, let's find the cost of third stage, seventh vertex. Cost of third stage, seventh vertex is minimum of cost of 7, 9 and the weight of this edge plus cost of fourth stage, ninth vertex, comma, cost of this edge 7, 10 plus cost of this fourth stage 10th vertex. So I'll get minimum of 4 plus 4 comma 3 plus 2, where minimum is 3 plus 2. Which vertex is giving 3 plus 2? This vertex, that is 10, right? So I can say if I move through 7 from 7 through 10, I will get a minimum cost compared to when I move through 7 to 9 and then 9 to 12. So what is the cost I got? 3 plus 2, 5. So in 7th vertex, I'll write the cost is 5. And moving through which vertex I get the cost? Moving through 10th vertex. So I write 10 here to say through which vertex I am going to the destination. Similarly, for the third stage, 8th vertex. Cost of third stage, 8th vertex is minimum of this edge, the weight of the edge, that is 8, 10 plus cost of 10th vertex, 4th stage 10th vertex, comma, this edge, that is 8, 11 edge plus cost of 4th stage 11th vertex. Substituting, we get 5 plus 2, 6 plus 5. So this is smaller. 5 plus 2, who is contributing? The 10th vertex is contributing. So we can say that the weight of this vertex is minimum weight is 7 if I move through 10. So under 8 I'll write 7 and going through 10. Similarly, we'll go for the previous stage, that is the second stage. Second stage, we have 4 vertices, 2, 3, 4 and 5. So we need to find cost of 2, 2. There are 3 edges coming out of this. So we need to find minimum of that. So we'll say minimum of C of 2, 6, that is this edge, which is 4, plus cost of third stage 6th vertex, and uh, this one, that is 2 to 7, the weight of this edge 2 to 7, and third stage 7th vertex cost, as well as this weight, that is 2 and 8, plus cost of third stage 8th vertex cost. So substituting, we'll get minimum of 4 plus 7, 2 plus 5 and 1 plus 7. Smaller is 7, 2 plus 5. Which node is contributing? The 7th node. So it says that if I move through this way, 2 to 7 and further, depending on the path that is suggested by 7th vertex, I'll get the minimum cost. So here under the node 2, we will write the cost is 7, that is 2 plus 5 is 7, and through which node I should go? Through 7th node. So I fill this. Now similarly, I try for 3, cost of 2, 3, that is second stage, third vertex, is minimum of C of 3, 6. There are 2 edges, one is 3, 6 and another is 3, 7. So cost of 3, 6 plus cost of third stage 6th vertex, comma, the weight of this edge 3, 7 plus cost of third stage 7th vertex. Substituting, we get minimum of 2 plus 7 and 7 plus 10. 2 plus 7 is minimum, that is the first term is minimum, which says that the weight, the shortest distance is 7 plus 2, that is 9, and it is moving through 6th vertex. So this is for this particular node, that is third node. So under 3, you will write the total cost is 9, and it is moving through 6th vertex. Similarly, we will find for 4. There is only one edge which is going out of 4. So it is easy for us to find. So we'll see the weight of this edge, that is 11, plus cost of this node, that is 8. So that we should pick it from here. The cost of this node, 8 node, is 7. From the table we need to pick. So 11 plus 7 is, how much is that? 11 plus 7 is 18. So we will say the distance for 4 is 18 and we will fill it in the table. And we are moving through 8th vertex. So 8 is filled here. Similarly for 5, we will see, when we see for 5, we have 2 edges that is going out. So we have to find the minimum. So minimum of edge, the weight of the edge 5, 7 plus third stage 7th vertex cost. it is given here, C of 5 comma 7 plus cost of 3 comma 7, as well as the weight of this edge 5 comma 8, C of 5 comma 8 plus cost of third stage 8th vertex. Now if you substitute, you will get C of 5 comma 7 is 11, and weight the cost of this node 7 node is 5, so 11 plus 5 we will get 16, comma this weight is 8 and cost of this node 8 is 7. 8 plus 7 is 15. So right, so you'll get minimum of 11 plus 5 comma 8 plus 7, that is 15. 15 is smaller. Who is contributing? Node number 8 is contributing for this particular node 5. So we'll write 15 and 8 is contributing. Moving forward, we are going to the last node, that is a source node. There are 4 different edges coming out from this node. So we need to find minimum of all these. So I'll say minimum of this weight, that is the weight of the edge from 1 to 2 plus cost of second stage vertex number 2, comma weight of this node 1 comma 3 plus cost of second stage third vertex, and weight of 1 comma 4 and second stage fourth vertex, comma weight of 1 comma 5 comma second stage fifth vertex. Substituting, we'll get minimum of 9 plus 7 comma 7 plus 9 comma 3 plus 8 and 18 and 2 plus 15. Now you will notice that both these are giving equal weight, 9 plus 7 and 7 plus 9. It means that either you move through node number 2 or node number 3, you will get the shortest path. So how do you put it in the table? You put 2/3, indicating that you can choose either of the nodes. So how do we compute how do we finalize the shortest path? So we say that first stage vertex 1, this is your first stage vertex 1, the minimum the node I should travel is through 2. Now I will, from 1 I will reach 2. From 2, which is the node I should travel next to, that is 7. So from 2 I'll reach 7. So I'll just plot this. I'm starting from here. From here it says that from 1 you can either go to 2 or 3. So let me choose 2 in this case. So I'm going to 2. From 2 it says that go to 7. So from 2 I will go to 7. From 7 it says that go to node number 10. So I'll say from 7 go to 10. From 10 if you see it says that go to 12. From 10 I will go to 12. So this is the path to reach the shortest distance. 1 to 2, 2 to 7 and 7 to 10 and 10 to 12. You can calculate the cost also, like it's 9 plus 2 plus 3 plus 2. 9 plus 2 is 11. 11 plus 3 is 14. 14 plus 2 is 16 is the shortest cost. That's all with multi-stage graph.